On page 268 is chapter 12, and it's all about sample surveys. Again, this is going to be just definition heavy, whether you know what they're talking about or not. So the first part of the chapter is talking about some of the things that are necessary in order to have a valid survey. And then next Monday, you'll get a reading assignment where you can read about all the different types of sample surveys. And then the next day, we'll talk about all the things that can go wrong with sample surveys. So if you want to follow along, it's on page 268. If you don't, I've got the gist of things up on the screen. So when you're doing a survey, obviously you're not going to survey the entire universe, right? So the first thing you have to do is somehow draw a sample some way, all right? You'd like to know about entire population, and when I say population, I don't mean as in the population of the United States. The population I'm interested in could be the Murray High football team, all right? So it's just a population as in a group of people, not as in the population of a country, okay? So we have to draw a sample because it's not going to be feasible to probably survey an entire population of people you're interested in. So when we do that, there's going to be different methods for selecting that sample. That's what we're going to talk about on Monday. But it's important to remember that you're always looking at a sample of individuals. You're never, hardly ever looking at the entire population of individuals. When you're looking at your results, you want to keep that in mind, that it's a sample. And then all of this is about surveys. So we will talk about samples with experiments in the next chapter, but all of this chapter is going to be just looking at surveys. So keep in mind you're always looking at a sample of a population. One of the biggest problems with a survey is bias. And there are multiple forms of bias, and we'll talk about some today and talk about some next week. But bias is going to be the biggest deterrent to getting an accurate representative sample. So if it's biased, it might not be biased. Like it can be biased because you're asking the question weird. All right, that could be totally, that's what you normally think of. Or it could be biased because you're only asking a certain group of people. But it could also be biased just because the sample that you chose wasn't great. All right. So if you somehow over or underestimate or underemphasize the characteristics of a population, then that's going to be the definition of bias. So it's not just doing one specific thing. So you want a survey, if you conduct a survey, to be representative of the entire population. So when you're doing that, you can't just handpick people. That would take too long. And so we always randomize when we're doing a survey, somehow, some way. Just like you randomize with a simulation, right? You use random digits to represent what was happening. Somehow they're going to hopefully employ randomization when you're doing a survey as well, okay? So if you don't use randomness, you may not be able to ensure that you have a valid survey. And so the randomness needs to be employed somehow. We'll talk about all those things later. They give you a really great example on page 269 in your book if you wanted to read through it. I'll give you kind of the synopsis. But there was, before Reader's Digest, there was Literary Digest, 1916, 1936, and they always did opinion polls. And then they always were doing opinion polls for elections, just like we do now. All right. So during the 1936 presidential campaign between Landon and Roosevelt, FDR, it mailed 10 million ballots to get an astonishing, and it got 2.4 million ballots back. All right, so it mailed out 10 million ballots to people, and they got 2.4 million back. All right, so they're trying to predict what's going to happen in this election. So the results from that 2.4 million was that Landon would be the had to be something wrong with what they did if they were so sure, like positive, like there was no debate, like he was going to win. Like it wasn't a close margin from their ballots. It was that this dude was going to win. All right. So let's talk about what was happening. I mean, you guys, we all know, you guys know more about history than I do. Like we're all on the same page about that. So if you think about it though, the sample wasn't representative. So they sent out 10 million ballots. So where would you probably get 10 million names in the 1930s? A telephone book, all right? And so a phone book would have only telephone numbers, right? In the 1930s, telephones weren't like something that everyone had. It was a luxury item. So they're drawing from a population of rich people. And so in this era, we're talking about coming out of the Great Depression. So one of the biggest campaign topics was they were talking about like the economy and, trying to change the gap between the poor and the rich right after the Great Depression. And so what happened was all those voters came out and voted for FDR because he had a better platform for that, right? So when they did this, sent ballots to people that had telephones, so they sent it to the richer population, so that wasn't a representative sample of everybody. So when I'm saying that there's going to be bias, like that is bias, unintentionally by this magazine, all right? But that's what happened, okay? So when you're thinking about bias, it might not always just be something that you just think about. It might not be on purpose, but you're having to somehow try to eliminate all of the bias from your survey, and to do that, you have to randomize, okay? That will hopefully eliminate everything for you. So when you're selecting people at random for a survey, you're generally still going to use a random number table or something, just like we did simulations. You're going to, so the Gallup poll, because we still have those, they still poll via telephone, but now they do a random telephone number generator. So that's why they may get a cell phone or a landline, so they're still being able to get a representative sample, hopefully, if you answer their questions. So randomizing helps you look at the population on average. Again, if you don't have randomization, I keep saying this over and over again, because it's the most important piece of these surveys, is somehow you randomize. Another important key to this is that you may think you have to have a certain percentage of the population in order to get a good survey, and that's not the case. So maybe you're looking at like all of the high schools in Kentucky, and you think that, okay, I have to have this % of the students to respond. Okay, that's not necessarily true. It's not really about the fraction of the people that you use. It's just about, is your sample size large enough to be representative? So it doesn't have to be a specific fraction of the whole. Okay, never. It's going to be, is the sample size large enough? And we're going to use that idea all the way through the rest of the book, right? Especially when we get into inference procedures after Christmas. When we're talking about population sizes and sample sizes in the scenario, it's always just going to be, is it large enough? Okay, so generally, there's not a fraction you're worried about, just as long as it's large enough to be representative of everyone. Okay, so you normally don't look at a percentage of people. It would be nice if you could do a census of everything, right? Census is where you poll or survey every single person in the entire population, but there are lots of problems with that. Lots of them. So it's difficult to complete a census, time, money, right? If you're doing the Morgan High football team, it's not a big deal, right? That population, you can do a census of that, not a big deal. If you're going to do a census of all the students in Kentucky high schools, right, that's going to take a lot of effort. Populations rarely stand still as well. You know this. If we're doing like all of the Kentucky high schools, we have students moving in and out of Kentucky at all times, right? They move into one high school, they go into a different high school, they move in from Tennessee. So a population is rarely stationary. A population of anything is normally in motion somehow, okay? So how do you figure out if you've polled them already, or if did you miss somebody? Like if you're working from east to west across the state and then someone moves in, do you go back and survey that person? How do you keep track of that? Again, it makes it not so feasible to do a census. And then taking a census can be more complex than sampling. There's all these extra little bits and pieces going on in a census, whereas a sample is just that. It's a sample. You get 1,000 responses and then you're done. It doesn't matter if you have to go back and see if someone transferred or not. Okay, so census sounds good in theory, not so awesome. If you're thinking about the U.S. census, do that, every 10 years? that's a nightmare. Now, back in the day, people would respond because they thought it was really important. Like when the census first started, people thought it was like really important to give their information. Now people are like, why are we still doing this? Like you get it in the mail and then like it's like this 10-page document if you get the long one, or that it's longer, and then if it's not, you get a short one. And if you want, do you really want to send it back? Do you remember to send it back? Then they have people canvassing to come get people's responses, but then people get doubled up. So if you have college kids, for example, if you're a college kid, they send census documents to colleges, to individuals, because they're technically adults. But then at home, your parents count you too, all right? So you can't keep track of, is this really accurate information, or are they doubling people up somewhere? So again, census becomes a complex being, and it's not always as easy. What? If you, 10 years when the U.S. does a census, you're supposed to turn it back in. Yeah, so then if you don't send it back, then they call you. Or they come to your door. They're really trying to get your information, but those people are just, people are like, I'm not going to answer the phone because I don't know this number, or I don't really want to answer the door because I don't want to talk to these people. So again, it becomes this big issue where it would be like, okay, why can't we just do a sample and just be done with this, okay? So census, complex. Some more vocabulary to know in this chapter. We're always talking about population parameters and the sample statistic, and those are not the same thing. All right, so a parameter is what you're looking for, like you're looking for the mean of everything, are you looking for the proportion of everything? The sample statistic is the actual number that comes from your model, like from your sample, okay? So there's what you're modeling or trying to accomplish, data. So I've got a chart down here so you can look at that, what I mean. Like we know that Y bar is the mean, right, when we have a sample set, right? So in the whole entire survey, like in the grand scheme of things, we're looking for mu, the mean of the population, right? That's what we're interested in. That's not what we're going to get. We're not going to get the mean of everybody, of our population. We're just going to get the mean of our sample, right? If we're looking for a proportion, we have p hat, which we haven't gotten to yet this year, but we have predicted proportion, right? That's what hat means, okay? But in the grand scheme of things, what I'm interested in is looking for p, the proportion of the whole entire population. What I'm really going to get is p hat. Okay, so the population parameters, what I'm interested in, it's not what I'm going to get. That's like what I'm trying to extend my results to be. What I'm really going to get is whatever I got in my sample. So this is going to be what you actually get, and that's going to be what you're trying to model. Okay? Just keep those two things separate. You're interested in something, it's your parameter. What you're actually doing is your statistic. This box kind of helps you if population model parameters are not just unknown. Usually they are unknowable. Okay, we can't do a census of everybody and get what we want. It would be nearly impossible. Okay, so we have to settle for our statistic. And again, we draw samples because we can't work with the entire population. But a sample does need to be representative of our population somehow. And again, randomizing and doing just some different things will ensure that that happens. And we will talk all about that next week. Okay, so the next little slide is the just checking on page 273. And all it's going to do is ask us to go through and explain why the claims that are made are incorrect. All right, is there something wrong? Is they using a different term they're not supposed to use? Is it biased? Biased, oh my gosh, biased, whatever. Okay, so we're going to look at them together. We can talk about them. Kind of put some of these things together. So on part A, they claim for the survey, it is always better to take a census than to draw a sample. Right, we've talked about this at length today, right? It's not better to take a census because it's too much work, time, money. It's more difficult. So it's always easier to take a sample. Today is the 24th. On part B, stopping students on their way out of the cafeteria is a good way to sample if we want to know about the quality of the food there. What is the potential problem with that claim? Right. Not everyone is eating the food in the cafeteria, right? Some people bring their lunches. Like if you're talking about a school cafeteria, they're bringing their lunches. People are eating their lunches. So if you're standing outside the cafeteria, you know, it's every single person. They bring their lunch. They probably bring their lunch for a reason. Either they don't like the food, can't eat the food. It's cheaper to bring their lunch, right? They're going to have some sort of negative response compared to the people that do. So if you're just worried about the quality of the food, you only want to survey the people that are actually eating the food. So that's a different population than what you're surveying. So you're introducing bias in part B because you're asking everybody that's in the cafeteria. And that's not going to answer your question. That's the wrong population to survey from. Oh, and see, we drew a sample of 100 from the 3,000 students in a school. To get the same level of precision for a town of 30,000 residents, we'll need a sample of 1,000. Do you need a specific fraction in order to do a sample? No. So this is trying to say, okay, if we're going to extend this, we're using the same percentage. That's not how this works. All right? You hardly ever going to get exactly that many people anyway. Okay? It's just that you don't have to do it that way. Like, it's not going to necessarily achieve the same level of precision. On D, a poll taken at a statistics support website garnered 12,357 responses. The majority said they enjoy doing statistics homework. With a sample size that large, we can be pretty sure that most statistics students feel this way too. So what's wrong with that? It's biased, right? They're talking about a statistics support website. If you care that much that you can't figure out your homework and you go to statistics support website, then you probably like statistics a little more than the average person, right? So that's definitely going to be biased. And then on E, the true percentage of all statistics students who enjoy the homework is called a population statistic. What's wrong with that? Right, you're talking about a population parameter, and then it would be a sample statistic. You cannot get a population statistic. Here. Even the census really can't get a population statistic because it's really not the actual number of people or the actual amount of this or whatever. Does that make sense? Okay. Just one more thing from the book, and then we're going to do just a few examples, and I'm going to give you a few to do in class today. All right. It's important to keep in mind that when you pick your population that you're going to survey from, that at every level that you're doing something, your your sample is going to get a little bit more condensed. And every single time you do that, you have to think about, okay, is this getting biased in any way, right? Each time you do something, you cut it down, and then does that change things? And we'll talk more about that when we do different types of samples. So you always need to specify the sampling frame. And the sampling frame is just a list of individuals from which a sample is drawn. So if you're going to just do a survey of random people with telephones, then you need your sampling frame is going to be some sort of list of telephone numbers, like a list from a telephone book or a list from somewhere. If you're going to do a sample of Murray High School students, I need a roster of Murray High School students. That's my sampling frame. I'm not going to survey everyone, but the people I survey are going to be within that list. Then there's the people, like your target sample. And that's who you intend to survey. All right, so you have the sampling frame. Somehow you're going to employ randomization, okay? Let's say for Murray High students, I take a list of Murray High students, and there's 420 students, and I number them 1 through 420, right? And I want to survey 100 of them. So I do random number generator until I get 100 students, okay? So I have my sampling frame, all the student body, but now my target sample is who I actually am going to survey, okay? Okay. And then there's your sample. So then maybe I'm only surveying on Monday, October the 27th. And 4 people in my target sample are absent that day. Then my actual sample is just the 96 people I actually surveyed. Right? My target sample was those 100 that I wanted, and then 4 of them were absent, so I'm only going to have 96. So at each level, right, this is getting a shorter and shorter list, right? Every time you do a survey, something's going to happen. Someone's not there, someone gets sick, right? Generally something's going to happen, right? Just human nature, something's going to happen. So you have to keep in mind, though, at every one of these levels, are you somehow introducing bias, okay? So by those 4 people not being there, is that going to be biased somehow? Generally, it's not going to be. But if you get these smaller and smaller samples, then maybe you're going to leave out a representative group or something. And then at each step, the group we can study maybe constrain further. So when I'm talking about checking for bias, but still doing the school example, we picked 100 students, 96 of them were here that day I surveyed. Let's say when I did my random number generator, the 4 that were absent were the only 4 freshmen that I was going to survey, just by chance. So have I introduced bias by those 4 being absent? Yes, I don't have a representative response from any of the freshmen, right? So I've left out a group of my population. Unintentionally, but it happened, right? So you should keep in mind at each level what's happening, okay? All right. So I'm going to do 3 problems with you, and I'm going to assign you a few to do. So just going over some of these ideas we talked about today. So at its website, the Gallup poll publishes results of a new survey each day. Scroll down to the end and you'll find a statement that includes words such as these. Results are based on telephone interviews with 1,008 national adults aged 18 and older, conducted April 2nd through 5th, 2007. In addition to sampling error, which we can talk about in a second, question wording and practical difficulties in conducting surveys can introduce error or bias into the findings of public opinion polls. Sampling error sounds bad. The other name for sampling error is sampling variability. It's just that every sample that you draw from your population is not going to be the same, right? All right. So for this survey, identify the population of interest. So from this paragraph, what was the population that we were interested in, the whole big shebang, population of interest? All U.S. adults, right, aged 18 and older. Number 5 is on page 2, what did you say, 88? Okay. On part B, Gallup performs its surveys by phoning numbers generated at random by a computer program. What is the sampling frame? What sampling frame is their list of individuals? Right, it's going to have to be some list of telephone numbers, right? Somehow, from a phone book or from somewhere. And then C, what problems, if any, would you be concerned about in matching the sampling frame with the population? All right, some people aren't going to answer. Some people don't have a landline anymore, right? And then you can have a do not call, like you can be on the do not call list on your cell phone, right? So you're not going to reach those people, right? If you have a cell phone, some people that have cell phones aren't 18 and older, right? And you're doing a telephone interview, so how do you know if they're just making stuff up? You know there's kids that would totally do that. There's lots of things that could be wrong with that. Agreed? Okay. the last two we're going to do are going to go through, there's like multiple things they want. You don't have to write complete sentences. We're just going to go through all the individual pieces to see if we can identify them all. So for the following reports about statistical studies, identify the following items if possible. So not everything is going to be listed. You might not always know all of the answers to all the questions. If you can't tell, then say so. This often happens when we read about a survey. Something's missing. So we want to know the population that they're trying to draw from, the population parameter of interest. So they want the mean of something, the proportion of something. What do they want? The sampling frame. What's their list going to be? The actual sample, who did they actually survey? The sampling method, for now, we're just going to talk about how they actually sampled if they tell us. Those have specific names we'll talk about on Monday. And then any potential sources of bias or any problems you could foresee. We're just going to list all those things out. So the first we're going to do is number 7. So Consumers Union asked all subscribers whether they had used alternative medical treatments, and if so, whether they had benefited from them. For almost all of the treatments, approximately 20% of those responding reported cures or substantial improvement in their condition. So what is the population, do you think, of people that they're surveying? Yeah, they only ask Consumer Union subscribers, right? So the population has to be people that subscribe to that, right? I mean, they didn't ask anybody else. All right, what's the parameter of interest? What are they actually looking for? A proportion that said that they're benefited, right? Okay. What is this sampling frame going to be? What is their list going to be? What's going to be their list of subscribers? Right? They're going to have a list somehow. The sample. So what's the sample going to be? They had their list of subscribers. What do you think happened? Yeah, people that actually responded. We can't guarantee that everyone did. Does it give any sampling method about how they did this? No, it doesn't say like we sent a postcard in the subscription or they sent an email to all subscribers. Like they don't say how they conducted the survey, so we don't know. And then F, any potential bias. And again, we'll go back and talk about some specific names of this later. Well, what could be wrong with this type of survey? Okay, they could have maybe not known the definition of what they're talking about, like what does alternative medical treatment mean to them, right? If it wasn't defined very well. If you get a survey in a magazine, how often do you send it back? No. Hardly ever. If you did, you probably had some pretty strong opinion, right? So there's going to be bias in the people that respond, okay? So it was totally voluntary, probably. So you're going to have some sort of bias because of the respondents. And again, we'll go back and talk about some specific names of that later this week, or next week.
Teachers find direction of the following students to report to the TV production lab. Sarah Whitman, Prashant Chakadar, John Kilsh, Elizabeth Bowman, Sam, Taylor, Ian Smith. And if they're taking the test, they can go after we finish the test. Thank you.
All right, we're just going to do one more of those. It's down here. Researchers waited outside a bar they had randomly selected from a list of such establishments. They stopped every 10th person who came out of the bar and asked whether he or she thought drinking and driving was a serious problem. So, what is the population as a whole that they're thinking about? Just like adults, right? Just generic adults. Does that make sense? On part B, what's the parameter we're looking for? The parameter is based on the statistics. So what are they interested in finding out? Right, the proportion of people who think drinking and driving is a serious problem. What is the sampling frame? Technically, what would be their list of individuals? They might actually have a physical list, but who are they sampling from? People at the bar. They might actually have an actual list, but that's the people they're sampling from. How did they, what's the next one? I forget. Who did they sample? Every 10th person. So then the sampling method is the same as we just said for D, right? They sampled every 10th person. So they actually told us what happened here. It's probably some sort of just verbal interaction, right? Some sort of interview. And then what type of bias could you see here? They're asking people at a bar. So maybe you're asking people that are intoxicated and could care less. Maybe you're asking the DD who's like, yes, it's a serious problem because I'm the DD today. Or I don't know. But you are having all sorts of crazy responses probably from the people you're asking. Agreed? Okay. So I just want you to do just to practice, make sure we have all those definitions straight. So on page 288, I just want you to do did. You're going to list out all the pieces.